Today we are going to be learning about multiples and factors. Let us start. Multiples. Mr. Gupta goes for a walk every morning. From the start, he steps on every third tile of the footpath. These are the multiples of 3. We can find multiples of a number by simply multiplying them from 1, 2, 3, 4 and so on. Properties of multiples. Property number 1. Every non-zero number has an unlimited number of multiples. For example, multiples of 6 include 12, 24, 30, 36, 120, 600, 6000 and so on. Property number 2. Every non-zero number is a multiple of itself. For example, 8 multiplied by 1 is equal to 8, which means that 8 is a multiple of 8. Another example, 249 into 1 is equal to 249, which means that 249 is a multiple of 249. Property number 3. Every number is a multiple of 1. For example, multiples of 1 include 1, 2, 3, 4, 100, 1000, 10,000 and so on. Property number 4. 0 is the multiple of every non-zero number. For example, 0 into 8 is equal to 0. 0 into 11 is also equal to 0 and so on. Property number 5. The first multiple of every number is the number itself. For example, the first multiple of 3 is 3. The first multiple of 8 is also 8 and so on. Property number 6. Every multiple of a non-zero number is either equal to or bigger than that number. For example, the multiples of 6 are 6, 12, 18, 24, 30, 36, etc. Property number 7. A multiple of a number is divisible by that number. For example, the multiples of 5 are 5, 10, 15, 20, 25, etc. and they are all divisible by 5. Common multiples. In the image shown to you, Mr. Gupta's steps are multiples of 3 and Mrs. Gupta's steps are multiples of 2. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30 and 33. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 and 34. Do you know which tiles do both Mr. and Mrs. Gupta step on? The numbers 6, 12, 18, 24 and 30 appear in both the lists of multiples. Therefore, they are the common multiples of 2 and 3. Factors. The numbers that we multiply to get a product are called its factors. For example, for a school dance, 18 dancers have to enter the stage together. The dance teacher drew different ways that they could do it. First was 18 students in one line, that is 18 into 1. Second was 2 lines of 9 dancers each, that is 9 into 2, which is also equal to 18. The third was 3 lines of 6 dancers each, that was 6 into 3 is equal to 18. Here 1, 18, 2, 9, 3 and 6 are all the numbers that we multiplied to get 18. Hence, all these numbers are factors of 18. Properties of factors. Property number 1. Every non-zero number has a limited number of factors. For example, the factors of 18 are 1, 2, 3, 6, 9 and 18. Property number 2. Every number is the biggest factor of itself. For example, 23 is the biggest factor of 23. 63 is the biggest factor of 63, and so on. Property number 3. 1 is a factor of every non-zero number, and it is also the smallest factor of that number. Property number 4. Every factor of a non-zero number is either less than or equal to the given number. For example, the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Finding factors of a number. Method 1. Using multiplication. Let's find the factors of 20 using multiplication. Let's try 1. 1 into 20 is equal to 20. Let's try 2. 2 into 10 is equal to 20. Let's try 3. But 3 is not a factor of 20 because it is not possible. Let's try 4. 4 into 5 is equal to 20. Now let's try 5, but stop. We have already found 5 as a factor of 20. Therefore, the factors of 20 are 1, 2, 4, 5, 10 and 20. How do you know when to stop trying to find factors? To find the factors of 32, we stop at 5 because 6 into 6 is equal to 36, which is more than 32. To find factors of 32, let us start with 1. 1 into 32 is equal to 32. 2 into 16 is equal to 32. 3 is not a factor. 4 into 8 is equal to 32. 5 is not a factor and we stop at 6. Therefore, 1, 2, 4, 8, 16 and 32 are all factors of 32. Method 2. Using division. We can also find the factors of a number by using the process of division. When we divide a number and there is no remainder, the divisor and the quotient are the factors of that number. For example, a group of 30 people visit a hotel. They want to sit in equal groups at the tables. The manager works out different combinations to make it happen through the process of division. If he places them all in one table, then there will be 30 in a group. That is, 30 divided by 1 is equal to 30. So 30 and 1 are both factors of 30. If he places 2 tables, there will be 15 in each group. That is, 30 divided by 2 is equal to 15, which means that 2 and 15 are also factors of 30. Next, if he uses 5 tables, then there would be 6 in each group, which means that 30 divided by 5 is equal to 6, and 5 and 6 are also factors of 30. Therefore, all the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30, which means that the manager can use these many tables to accommodate all the people at the hotel. Building factor trees. We can build many numbers using 2 or more factors. Let us take an example of 8. 8 has 2 factors, 4 and 2. 4 further has 2 more factors, that is 2 into 2 is equal to 4. Therefore, 8 can be built on 3 factors, that is 2 into 2 into 2. The factor tree helps us to find different ways of making a number by multiplying. This is a factor tree shown here. We try to give it as many branches as possible. We can break the circled number further. We stop when we use 1 as a factor. Let us make 2 more factor trees for the number 18. We start the number from the top and go down to the bottom. A. 18 has 2 factors, 9 and 2. 9 can be further have 2 factors, that is 3 and 3. So 2 into 3 into 3. Another 18 has 2 factors, 3 and 6. 6 further has two more factors, that is 2 into 3. So 3 into 2 into 3. The last row in both the factor trees have the three numbers 3, 2 and 3. Different types of numbers. Odd and even numbers. Numbers that are multiples of 2 and that leave no remainder when divided by 2 are called even numbers. In the set of the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, the numbers 0, 2, 4, 6, 8 are all even numbers. Similarly, all the numbers which end with 0, 2, 4, 6 and 8 or which have them at the ones place are divisible by 2 and are all even numbers. Numbers that are not multiples of 2 are called odd numbers. In the set of 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, the numbers 1, 3, 5, 7 and 9 are odd numbers. Prime and composite numbers. A number that has only two factors, 1 and the number itself, are called prime numbers. For example, factors of 2 are 1 and 2. Therefore, 2 is a prime number. Similarly, factors of 3 are 1 and 3. So, it is also a prime number. Thus, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 are all prime numbers. Numbers that have more than two factors, excluding 1 and the number itself, are called composite numbers. For example, 4 is the first and the smallest composite number. 0 and 1 are not prime numbers because 0 cannot be divided by itself and 1 has only one factor, namely 1. 2 is the only even prime number. All numbers except 0 and 1 are either prime or composite numbers. 0 and 1 are neither prime nor composite numbers. Rules of divisibility. Is it possible for you to say whether a number is divisible by another number without actually doing the division? Yes, by following these rules of divisibility, you can say so. Rule number 1. Divisibility by 2. A number is divisible by 2 if the last number or the number in the ones digit is either 0, 2, 4, 6, 8. For example, 14, 28, 32, 456 are all divisible by 2. But 1945, 55, 73, these are not divisible by 2. Rule number 2. Divisibility by 3. A number is divisible by 3 if all the digits and their sum is divisible by 3. Let us take an example. Is 3, 4, 8, 2, 1 divisible by 3? Add 3 plus 4 plus 8 plus 2 plus 1. This gives us 18 as the answer. 18 is divisible by 3. Therefore, 3, 4, 8, 2, 1 is also divisible by 3. Rule number 3. Divisibility by 5. If a number is divisible by 5, the digit in the last or the ones place should be 0 or 5. For example, 10, 15, 20, 25, 30, 35 and so on are all divisible by 5. But 54, 72, these are not divisible by 5. Rule number 4. Divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. Rule number 5. Divisibility by 9. A number is divisible by 9 if the sum of all numbers is also divisible by 9. For example, 67041 is divisible by 9 because 6 plus 7 plus 0 plus 4 plus 1 is equal to 18, which is also divisible by 9. But 52066 is not divisible by 9 because the sum of all these numbers is 19, which is not divisible by 9 either. Rule number 6. Divisibility by 10. A number is divisible by 10 if the last or the ones place digit is 0. For example, 10, 20, 30, 500, 600, 4600, 58,700, all these are divisible by 10 because the end digit is 0. But 544, 765, all these are not divisible by 10.